All right, so we are in section 3.2, measures of variation. Back in 3.1, we looked at measures of central tendency, where you're using an average of some type to summarize where most of the data lays. So in this section, we're looking about how spread out the data is. In 3.2, we look at what's called the range, the variance, and standard deviation of data to accomplish this. In other words, we're looking at measures of variation. The easiest one to find is the range. That's just the highest data value minus the lowest data value. When you get more precise, you're looking at variance and standard deviation. So variance and standard deviation tell us how far our data is spread about the mean, the average, right? Variance equals the standard deviation squared. Standard deviation is in the original units of our data. So like, for example, the standard deviation might be in inches, whereas the variance would be inches squared, that type of thing. Formulas here are sample standard deviation, represented by a lowercase s, is the square root of, in parentheses, look at the numerator, your x value, your data value, minus the mean of those values, in parentheses squared, divided by sample size, which for samples, it's a lowercase n, minus 1. The reason for the minus 1 is it gives you a more precise idea based on the small sample that you took. So it helps exclude extreme values that might throw off what you get for your sample standard deviation. If you square S and get rid of the radical sign, you get the sample variance S squared, which is the sum of the X minus X bar in parentheses squared divided by sample size N minus 1. For the population, instead of S, population standard deviation is represented by this letter sigma, which is the square root of, in the numerator, the sum of, is what that means, summation notation. In parentheses, X minus U, close the parentheses, squared, divided by the population size is referred to with the capital N. And then if you square that and get rid of the square root, you have what's called the population variance, the sum of X minus mu in parentheses squared divided by N. Notice in the formulas above here, let me slide back a little bit. Notice when you're working with samples, you're dividing by N minus 1. Populations, you're working with N. So be very aware in the problem you're working, is this a population or a sample that you're working with? So here's an example that I've typed out to show you if you're doing this without a graphing calculator, for example. Calculate the sample variance and sample standard deviation for the following, and I just made up some numbers here: 45, 23, 52, 33, 29. Note that the sample size n equals 5, right? So if you're doing this with just a regular calculator, not a graphing calculator, you start with the X column. So this is your actual data: 45, 23, 52, 33, 29. You get to the bottom of that column, you find X bar, because we're doing samples, so it's X bar. That's going to be the sum of all of your X's, adding all of these up in the X column, which turns out to be 182, divided by your sample size N, which is 5. 182 over 5, I rounded it to 36.4, okay? Next column, you take each X value from the first column and subtract this X bar 36.4. So for example, we'll have 45 minus 36.4 equals 8.6, and so on, all the way down to the 29 minus 36.4 equals negative 7.4. Then you take these values of the X minus X bars that you calculated and you square them. So for example, 8.6 squared gives you 73.96, the way I rounded it. All the way down to negative 7.4 in parentheses squared is 54.76. Then you find S squared. All of these data values that are in the X minus X bar in parentheses squared column, you add them up. Here's the summation notation right here. The sum of, in parentheses, X minus X bar squared divided by sample size N minus 1. That turns out to be 563.2 divided by 4, which is 140.8. So then the actual standard deviation, you take the square root of that, and I approximated it to 11.87. Now, this can be done on the graphing calculator, and I recommend highly you are using a TI-84 Plus, which is what I use. If you have a CE, some of the ways you access the information is going to be different than the way I do it on my TI-84 Plus, just so you know. But you should, I would imagine if you bought one, you have a book that goes with it, right? That tells you how to do it. It's like has a statistics section. All right, the next thing you need to be able to calculate here is something called the coefficient of variation, and it allows us to compare measurements from different populations. The units actually cancel out, like inches in the top, inches in the bottom, they cancel out. Here's the formula for that. Coefficient of variation equals sample standard deviation divided by X bar times 100. Gets rid of the decimal point. And I would recommend that you look in the textbook at example 8 on page 105 for the coefficient of variation. Chebyshev's theorem is the next thing we're going to look at. For any set of data and for any constant k greater than 1, the proportion of data that lies within k standard deviations on either side of the mean is at least 1 minus 1 over k squared. So I put something here about reading over the results of Chebyshev's theorem and then read over example 9 on page 107. I want to take a look at that. Oh, here's example 8 you can look at on page 105 for calculating coefficient of variation. And I want to go on and on and on. Here we go. Chebyshev's theorem. So here's the actual theorem itself that you can look at. I've already given it to you. Here's the results of Chebyshev's theorem. For any set of data, at least, that means it's that or more, at least 75% of the data fall in the interval from mu minus 2 sigma to mu plus 2 sigma, plus or minus 2 standard deviations of the mean. At least 88.9% of the data fall in the interval from mu minus 3 sigma to mu plus 3 sigma, plus and minus 3 standard deviations of the mean. And then at least, again, that means it could be more. 93.8% of the data fall in the interval from mu minus 4 standard deviations to mu plus 4 standard deviations. So let's go down to the next topic. And by the way, note that there are recommended homework problems that you try out based on the information that we've covered, okay? And remember also that for these T-books that we have online, the problem numbers, if you work the problem out, there's a little tab at the bottom where you can press it and it will tell you the correct answer. So you can check your work, as well as going back and looking at examples where they show you step by step in the book. All right, so here's how you're doing it. If you're like making a table or something like that and you're not using the graphing calculator, you make a frequency table as if you're constructing a histogram. You find the midpoint for each class, you call it X. That's what they call it in the textbook. Find the frequency F for each class, and then find N, which is the sum of all of the frequencies. And then in this case, to calculate the sample mean X bar, you'll take all of your X times Fs, sum them up. That's what this is, summation notation right here. You're going to add them up and divide by N. And that's then you can calculate the sample standard deviation once you found X bar, right? So the sample standard deviation is the square root of the sum of, in parentheses, X minus X bar squared divided by sample size N minus 1. Now you can do this easily on a TI-84 calculator. You enter the midpoints in list 1, frequencies in list 2, and then use single variable stats L1 comma L2. So let's take a look at an example of this grouped data. Actually, let me pause this while I'm going to bring it up. Ooh, and here, actually, I need to backtrack this because I wanted to show you how to do these calculations we looked at just a few minutes ago on a graphing calculator. So here's my TI-84. I'm going to press Stat. I'm going to press Edit, which is option number 1 under Edit. So you could just press Enter. And what we're going to do is we're going to enter this data into this first list. Okay. So I have my 45, and then I press Enter, 23, press Enter. Sorry, I did this out of order. 52, press Enter, 33, press Enter, and then 29. Then we're going to do second, and then above mode, you'll see the quit. You see it says quit. So I'm going to do second and then quit, and it gets me out of this, right? And so then I'm going to do stat, and I'm going to arrow over at the top to calc, and what we're doing is single variable stats that were in that first row. Press enter again. Here we got it. The mean of that data is 36.4, as you can see here on the screen. Sample standard deviation, I rounded it off, but it's approximately 11.87 is the way that I wrote it, doing it by hand over here. And again, sorry I did that out of order. Let me pause and get ready again. All right, now back to the future. We're looking at grouped or repeated data. So I'm going to bring up this problem for us to look at. This is problem 27. It's on page 111 in your T-book. And I recommended, if you look under the recommended homework, problem 28 for you to be able to do this, all right? So what was the age distribution of prehistoric Native Americans? Extensive anthropologic studies in the southwestern United States gave the following information about a prehistoric extended family group of 80 members on what is now the Navajo Reservation in northwestern New Mexico, and they give you the source. All right, so here we go. We have the age range in years, and then the number of individuals that fall into that age range. So for example, 1 to 10 years, there were 34 people. 11 to 20 years old, right? 18 people, and so on. 31 and over, there were 11, okay? And so for this community, estimate the mean age expressed in years, the sample variance, and the sample standard deviation. Notice because of this 31 and over, it says for the class of 31 and over, use 35.5 as a class midpoint, because what we want to do is enter the class midpoint for all of these age ranges into list 1 of our calculator. We're going to enter the number of individuals into list 2. And then I'll finish it up and show you how to find out the standard deviation and mean and all of that. So what we're going to do here, let me just double check and make sure that I'm recording. Yep. Just wanted to check. All right. So we're going to go into stat, press the stat key, press edit. Now see this information that I had in here from a previous explanation earlier in these notes. I'm going to get rid of it. So I'm going to arrow up, highlight the name of the list where you want to delete the information, and just press clear. And then press enter. Now this is important. Do not press the delete key, DEL. That will delete your entire list. There is a videotape that shows you how to retrieve a list that you accidentally erased or deleted, all right? So if you need to go back to Canvas and look that up, if you run into that situation, do it. So here's the idea. For list 1, we're finding the midpoint, okay? So here's how you do it. You do you add these together and divide by 2. So you do 1 point, or 1 point, you do 1 plus 10, you divide by 2, you get 5.5. And then press enter, all right? For the 11 plus 20 divided by 2, you're going to get 15.5. Press enter. 21 to 30, add them together, divide by 2, you're going to get 25.5. And then 31 and over, notice that they told you to use 35 points. It's like they're going up to 40. But at 35.5, use that as the class midpoint. So here's my 35.5. Press enter. All right, now I'm going to right arrow and go to list 2, and I'm going to enter the number of individuals in list 2, pressing enter after each entry. There's there's 34, press enter, 18, press enter, 17, press enter, 11, hold for it, press enter. All right. So now we're going to do second quit, which is above the mode key. Then we're going to go back into stat, and we're going to arrow over at the top to calculate. So I arrow to the right. Here's what we want to do. We want to do, and this is in your notes, by the way, it explains this. Single variable stats, that's option number 1. We're going to press enter. Now, we've entered data into 2 lists, list 1 and list 2. If you look at your numbers down here at the bottom, specifically number 1 and number 2, those keypads, you'll notice above number 1 is L1 and above number 2 is L2. That's list 1 and list 2. So to access those, we're going to press second and then the number 1, and there's list 1. Then we're going to do a comma. Then we're going to do second and press the number 2 to access list 2. Now we're going to do enter, and here we go. The mean for this data is 16.125. Sample standard deviation is, well, here's the whole thing. Let's say it's approximately 10.95. And then for the sample variance, you would square that. 10.95 or however far you carry it out, you would square it. Let me pause it. All right, resuming recording. So here's your recommended homework. Again, look over the examples where they work it out for you, and wherever you see tech notes involving the TI calculator, make sure you look over that. That's where I got this stuff right here, how to use the single var stats. But I recommend you look over all of these problems. If you have any questions whatsoever, please feel free to contact me. I'm going to save section 3.3 for the next video just for time's sake, so it's not like about an hour long or something like that. So stay in touch. If you have any questions, email. If you need to get with me Zoom wise, let's do that too.